saying that JP is a more solid version of Fisher. So okay, let's take a look at these non-right angle triangles, and of course my obligatory but always sincere thank you for showing up for your learning. And here we go. So what if I told you that you could apply sine law and cosine law even when you have a 90-degree triangle? But the fact is, like, the sine of 90 is 0. Sorry, the sine of 90 is 1, and the cosine of 90 is 0. So your laws just reduce anyway to SOHCAHTOA in those cases, or Pythagorean theorem. But otherwise, yeah, you can. You don't have to do that. Oh, my son has the same hat, and he's 4 and loves it too. I'm glad you all share interests with a 4-year-old. So let's keep going. Okay, important to note, there's no such thing as an opposite, adjacent, and hypotenuse when we're looking at these types of triangles. We just label them in this way. And there's sets of information here. Little a corresponds with angle A. Little b side B corresponds with angle B, and angle C corresponds with side C. It's kind of the neat logic of these triangles. Why is that logic? If I open up an angle with my hands, notice as the angle increases, the distance between my fingers increase. So that angle is opening up that side of the triangle. So that's why as that angle grows, that side grows. Okay, so sine law can be written this way. Okay, and if you go down to your handouts, one of the challenge problems is prove to me sine law. Prove that sine law is true, use only SOHCAHTOA to do that. You can do it. I'll do it for you. You can learn to do it too. Okay, so you can write sine law this way. You can also flip the whole thing over. And you want to have this ability to just say, well, I know that if that's true, then this is also true. A over sine A is equal to B over sine B is equal to little c over sine C. That's also true. Because you can flip equations like that. And that's one of your inverse operations that you can do. It's the same thing as raising both sides of an equation to the -1. Just flip it. Okay? And why is this useful? Well, if I want to find the length of AC, so I will label that little b, okay? And then I notice that if I use like this as my little mini equation to solve that, my unknown would be on the bottom. And when your unknown is on the bottom, isn't that just the worst? So why not write it the other way? Okay? It's the difference between having 3 inverse operations that you need to do or 1. So choose 1. 1 is easier than doing 3 things, easier to do 1 thing. So let's go. This is how we would write it down. We would say, okay, I notice that I have this pair, A and little a. Okay, so I'm going to use A over sine A is equal to B over sine B. And then I zoom in. I copy my equation out first. I usually advise you always write out your equation, but honestly with these trigonometric ones, I barely have the patience myself. Okay, and then I substitute in my values. A is down here. This is equal to A, and this is angle A. So I have 23 meters over sine of 73 degrees is equal to side length B that I've been asked to find. I've been asked to find the length AC. Okay, side length B is going to be equal to that over sine B. Sine 42 degrees. All right, now I get out my inverse operations pen. And I have one and only one inverse operation that I need to do. Multiply both sides by sine 42. Multiply over here, sine 42. Okay, and then I get this beautiful expression, which is an exact value expression for B, because this cancels that, and so I'm left with B isolated on that side. I have B is equal to 23 multiplied by sine 42 divided by sine 73 degrees. Now, before calculating the answer, make your guess. What would you guess that B is equal to, or a side length AC is equal to, if you knew that a 73-degree angle in this triangle opened up a side of 23 meters? You're guessing 17? Cool. Write it down and put a question mark. That way you can kind of put your guess where your mouth is, or at least where the mouth of the triangle is, and then test your guess. Let's find out. It's probably sitting over there with a calculator, and it's like exactly that. So anyway, whatever. We'll let him have his moment. Okay, clear your calculator. 23 multiplied by the sine of 42. On this calculator, I put in 42, and then I take the sine of it. That there is the sine of 42. If I push equals, that's what's on top of my equation, 15.39. And then I divide that by sine of 73. 73, but I take the sine of it. Notice that the sine of 73 is a little bit less than 1. It's pretty close to 1, though. And then we get 16. Oh, I guess the 17 was pretty darn good. 16 meters equals B. There we go. That's a big triangle with a 16-meter side. Voila. Notice one inverse operation because I flipped the equation. Cool. Yeah.
Do you flip the equation when you're finding a side?
I put my unknown on top is the general thing. And so I organize my equation to give me the fewest possible inverse operations. As much as I love me some inverse operations, I love me getting an answer more. So I'd rather do fewer inverse operations. All right, let's take a look at this one. If I want to solve for angle, where it is, find angle P. Okay, this angle here. We want to find this angle P. Okay, problem with that is I don't even know what little side P is. P is equal to, I don't know what it is. I don't know. So how can we solve for this? Well, is there another piece of information that I could solve for? He thinks about picking on people who might not be paying as much attention. What other piece of information could help me find angle P? Yeah, well, these aren't right angle triangles, so I don't really have opposites and adjacents. If I had angle R, could I find angle P? Can I find angle R? Yeah. See how easy that was? So it's I notice that I have this pair of information here. Whenever I have that pair of information, I can use sine law. Sine law is comparatively simple compared to cosine law. So use sine law when available. Here, if I don't have this pair, like any pieces of that pair, I need to go looking for something else. And the other thing that I see as well, I can find angle R here. If I had angle R, I can use a little strategy to find angle P. What will my strategy be when I have angle R? Yeah, they're going to P plus R plus Q will add to 180. So we're going to use that later once we find angle R. Wow, amazing. It's good stuff. The hive mind is working well for these problems. Let's find angle R. So in this case, put your unknowns on top. Sine R over R is equal to sine Q over Q. Notice it doesn't matter what the letters are. And this causes so many problems with cosine law you wouldn't believe. But just remember, it doesn't matter what letters you use, but it does matter that your letters correspond in the correct way. Okay? Q corresponds to this side. R corresponds to that side. Okay, so let's set it up. Sine R, we still don't know this angle R, so that's my unknown, over 41 is equal to the sine of 39 degrees over 28. And that's a lot of scribbling on your diagram, Mr. Jennings. Get rid of your scribbling. Okay, there we go. Okay, let's keep going. We have one and only one inverse operation we need, so the inverse operation pen makes one appearance in this problem. We're going to multiply both sides by 41. Okay. When I do that, the 41 cancels the 41 and has isolated R. And there is still kind of one inverse operation. It's taking the inverse sine of both sides. But what this will give you is yeah, I could write it out. Sine r is equal to 41 multiplied by sine 39 degrees over 28, and then you take the inverse sine of both sides. Cancels, because we're inverting the effect of sine, so those go away, and that isolates r. Okay? That's how you get r is equal to all this stuff. And this is what we're going to punch on the calculator. First, let's evaluate that, and then we'll take the sine inverse of it. Okay? So this is how it will look. I'm going to do 41 multiplied by the sine of 39. On my calculator, I write 39, then take the sine of it. Notice that that's 6.62. Oh, right. Before we do that, guess. What angle do you think? Guess. Quick. 67 degrees. Are you serious? Did you work it out already?
That looks like 68, actually.
It works like 68? I happen to know it's like 66.6 or something like that. Okay, so there, this is 41 times sine 39. We divide this by 28 equals 0.92, and then we take the inverse sine of that, 67 degrees.
Darn. Wow.
I mean, that one's not quite a 90 degree.
I was so close.
Okay, and now we want to find angle P. Okay, this is what we were looking for. And this is no longer a question. It's 67.1. We're going to just keep no decimal places because who cares? No, it's just like get to the degree. That's fine. We're just proving we can do trigonometry right. Okay, so that's all we're doing. We're not putting people on the moon. So if I knew that P, angle P is equal to the whole triangle minus angle R, which is 67, minus 39, well, then we would just evaluate that. So anyone do that in their head? Yeah? 74, good. P is equal to 74. I believe you. Cool. So then that's what P would be. And are people comfortable with setting up that step? People know how to do that? The way I do it is a little different, and they didn't like it in the morning, so I didn't do it my way here. My way is to say 180 degrees is equal to the three angles added together. I put in my known angles, and then I subtract them, and I end up with this line. Everyone was like, no, we do it in one step, Mr. Jennings. You got to skip steps there to do it the way we do. And usually I get in trouble if I skip steps in front of you. But here I'm skipping steps. Everyone likes it? Great. Cool. Fantastic. So that's how you would solve for that angle, using sine law. Okay, cosine law. Notice the jankiness of the cosine law. When you go to do your bonus questions, your challenge questions, many of you, I believe, will be very successful in proving sine law. If you ask me to go to that board back there and prove cosine law, I might say, give me a second. Let me remind myself of how to do it. Okay, proving cosine law is a little trickier. And it's a trickier formula, as we can see. So let's take a look at how we use it. These are two rearrangements. We had two rearrangements of sine law, which was just flip it. Okay, this one has a bit more doing to rearrange. They're identical. They're just rearrangements of one another. Okay, in this one we rearrange to isolate the angle, and this one it's rearranged to isolate the side. Okay, so otherwise they're identical formulas. You only need to memorize one if your algebra is good. Okay, might be the second tattoo you get underneath the quadratic formula. Memorize these things, or it might show up on your cheat sheet. Let's use it to solve for a side. First, we're going to copy out our formula. A squared equals b squared plus c squared minus 2bc cosine A. Okay, and then we're going to rock and roll with that formula. Uh-oh, I want to solve for side C, not side A. Does it matter what letter I use to label my unknowns? No. So let's remember that this is like angle A in the formula, and this is side A. These have to correspond. They have to be on opposite sides of your formula. So I'm going to actually just take a moment to avoid confusion and rewrite it this way. C squared equals A squared plus B squared minus 2AB cosine C. Okay? Notice B, C, BC. A, B, AB. C, big C. A, big A. Notice the correspondences are all the same, but the letters all changed because letters are arbitrary, but the mathematical relationships are necessary. Okay, and I erased an A in there. I'll get that in just a second. Okay. He said he would go fast, and then he talks for a long time. All right, now we can plug and chug our stuff. So, first, start with a guess. Give me your guess. How long is C going to be?
5.
You're thinking 6? 6, 5. Could it be as small as 2?
6.66.
Why can't it be as small as 2? Huh?
6.66.
Huh? Why couldn't it be as small as 2? Why is 2 not possible? No, I'm not worried about the degrees. I'm actually thinking a little bit differently than that. Okay. I was talking about this in the morning, and this is something that I want you to see. It is a little bit of a digression. So for this one, we would be guessing our side length C between values 19 and 3. The side C can't be shorter than 3, and it can't be longer than 19. So that constrains your guesses, and it builds your intuition and your algebraic understanding of triangles with your intuition about how big they should be. Both are valuable mathematical thinkings. Like I guess it's 6, and I calculate it to be 6.3. Both are equally valid and important mathematical processes. We tend to train the latter more. Okay, so now here, let's go C squared. C squared is equal to 8 squared plus 11 squared. That's 64 plus 121. Your calculator tells you that that's 185. 185 minus 2 times 11 times 8. That's 88 times 2. That's 176. So it's minus 176 times the cosine of 37 degrees. I like to do as much as I can outside the calculator as possible because I make fewer mistakes in my mind than I do in the calculator. I also have a record of the work I did so that I can find a mistake if one exists. If I'm punching in calculator stuff and my calculator outputs a number like 21, and I know the side can't be 21 because that would be longer than 11 plus 8, I can find my error easier here. Okay? So now, I'm going to go ahead and plug and chug. I can't simplify that anymore in my head. So I go 185 subtract the result of 176 multiplied by the cosine of 37. So on this calculator, I do 37, but take the cosine, equals a 44.4. Oh no, our guess was really wrong. We guessed 6 or 5, but it turns out to be 44.4. Nadia's laughing at me. She sees what I'm up to. What am I up to here? Is my calculator wrong? Why is it not wrong? Okay, good. Thank you. That's C squared. C squared is 44.4-ish. So then we raise both of these to the 1/2 to get our answer. So that is C to the 2 times 1/2, which is C to the 1, which is C. C equals, raise this to the 1/2. Oh, just take the square root. Okay, come on, take this. 6.66. Yeah, you did. It's more 6.7. Okay, so that's how you use cosine law to solve for an unknown side. Hooray! Okay, all right. That's how you do it. You saw it here first. No, you didn't. You saw it in grade 10 first. Unless you were absent that day. And then the review day, and then the take up the quiz day, and then all the days where the teacher did this in front of you. Yeah. All right. What if we're solving for a side, or sorry, an angle? Okay. Over here, no, you could use the unrearranged formula and then do inverse operations. Yeah, it's always a stylistic choice, right? Rearrange the equation and then sub in, or sub in and then rearrange the numbers. It's up to you. You can rearrange the numbers. It might be simpler.
All right.
Okay. You can make triangles in this way and then calculate the angles between the triangles without a protractor and a ruler. Okay. You notice here we have a good triangle because none of these values violate those inequalities I showed you over there. All of them are valid. So cool. It will make a triangle. And then we can calculate for the angle Z in this way. Just go ahead and label it. And then notice that this is like little z is equal to that. And this is little x is equal to that. And this is equal to little y. All right. And then we're going to go ahead and get lots of paper here so that we can do our formula up nice and high. And we're going to have cosine, I'm going to do this in black. Cosine of z is equal to a squared plus b squared minus c squared. So it's going to be 6 squared minus 8. Oh, I should copy out my equation. Sorry. Do an equation first. Little x squared plus little y squared minus little z squared, all divided by 2xy. Okay, that will be the cosine. Now, what's the maximum value that cosine can give you? What's the range of cosine x? This is useful to know. And we're going to definitely need it for next unit. The range of cosine x. Let's look at it in Desmos then.
It's less than 180 degrees.
Yeah. Oh, I have no internet. Oh, my. Okay. Let's not worry about it. Okay. The range of cosine is between 1 and -1. I'll just tell you. Okay. And this is, why is that? Well, cosine is a ratio of the hypotenuse to the adjacent, right? From this angle here. Okay. If the angle is 0, then the adjacent is the hypotenuse and the ratio is 1. If the angle is 90, it's 0. And if the angle is 180, then it's -1. And we'll see why soon when we look at the unit circle and angles in standard position. Stay tuned for Monday, everybody, Monday. Okay, so we're expecting an answer here on this side of the equation to be like within that range or that domain of that, or range, or whatever. Okay, so let's go. Let's sub in. Cosine of z is equal to, we have x squared is 9 squared. Oh, no, it's not. 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 8 squared plus 6 squared minus 9 squared. It's important you get the negative in the right spot. Notice I used this equation here, but instead of big A and little a, I have big Z and little z. And then everything else lines up in the right spot. The letters you use are arbitrary. The relationship between the letters is necessary. Which one is the negative one? Oh, if the angle here and the corresponding side are the one, that's the one that's negative, and it's also the one that does not appear down there. Okay?
Wait, what was that thing about the -1 sine y? Is it like between?
I'll show you in just a second as we evaluate this. We'll see. So because this is a good triangle and we have values that work, we're going to have 2 multiplied by 8 multiplied by 6 down there. All right. And so now let's work that out. 8 squared plus 6 squared happens to be 100. And 100 minus 9 squared is 100 minus 81. That gives us 19 positive over 2 times 8 times 6, which is 8 times 6 is 48, and 48 times 2 is 96. Someone said 96 over here. That's good. Yeah. Good job. Yeah. Okay, 19 over 96. Notice that 19 over 96 is between -1 and 1. And if you get a negative number, don't be surprised. That's fine. That's okay. And then we'd say, well, that's the cosine of z. So take the inverse cosine of both sides. And then you will have z is equal to cos inverse 19 over 96. Oh, but Mr. Jennings, my calculator gave me error. And I'll tell you why your calculator gave you error. It's because you didn't use brackets. And you punched in this, cosine inverse of 19 divided by 96, okay? You did that on your calculator. There ain't no angle that has a cosine of 19 because the domain and range of cosine is limited to -1 to 1. So there's no angle that has an adjacent that's 19 times bigger than the hypotenuse. Doesn't exist in our universe. Hypotenuse is always longer. So let's not do this. Use brackets around the argument of your trigonometric functions. The argument means the thing you're taking the cosine inverse of. Okay, use brackets there on your calculator. So this is what it would look like. Instead of saying like this, 19, but I take the inverse cosine of it, invalid input, blah, blah, blah. That's what I was showing you. Don't do that, okay? Do this, 19 divided by 96 equals. Doing that first is effectively putting it in brackets. And then I take the inverse cosine of it, tells me 79 degrees. So this is 79 degrees. Done. So that is the lesson. You said you wanted time to work, and I will say goodbye.